I'm going to go over a couple of ideas regarding projectile motion. And remember that we're still using the initial concepts that we introduced in class about 6 weeks ago, that average velocity. Remember, if you ever have to find anything's average velocity, you don't have to memorize anything, because average velocity simply means how much displacement have you covered over a particular time interval. How much have you been displaced in a particular time interval? So your displacement, whether you choose to write it as a d or an x, doesn't make a difference. You can also write it as a y, because if your displacement is horizontal displacement, I typically write it as an x. If your displacement is vertical displacement, I'll typically write it as a y. But some teachers, just to prevent any confusion, just use a d for displacement. And remember, displacement is slightly different than distance, because displacement takes into account your direction. So keep this in mind, that average velocity is total displacement over total time. How much have you been displaced, and in what time? How long did it take you to be displaced, that amount? The other thing you got to remember is that average velocity, if there is a constant acceleration isn't changing, and we're dealing with gravity all the time on the vertical axis, so that acceleration is constant. So when acceleration is constant, average velocity can also be determined by taking the sum of your final and your initial velocity and then dividing it by 2, just like you would take the average of any two numbers. You would add them together and then you divide by 2. So these aren't equations that you have to memorize. You just have to keep in mind that they are logical concepts. So keep these two in the back of your mind today when we discuss projectile motion. You don't have to memorize it, just ask yourself, what is average velocity? How is average velocity related to your initial and final velocity? And it's simply the sum of the two divided by 2. And how is it related to displacement and time? Simply displacement divided by time. That's how you get meters per second, or kilometers per hour, or miles per hour, because it's displacement over time. The other concept you have to keep in mind is the idea of acceleration. Once again, you don't ever have to memorize the equation of acceleration. You just have to ask yourself, what is acceleration? And when I ask myself what is acceleration, the answer comes up is that acceleration means I'm changing my speed. I'm changing my velocity. Because when I'm on the highway and I accelerate, I'm speeding up. Or if I have a negative acceleration, I'm slowing down. In that case, negative acceleration would be a deceleration. But I don't like using the word deceleration, because remember, the negative acceleration just means the acceleration is in the opposite direction of my original motion. So I like the idea of negative acceleration and positive acceleration. So the idea is that acceleration is a change in my velocity, and it's a rate of change. So things don't change immediately, they take a little bit of time. So the idea is that acceleration is a change in velocity with respect to a change in time. And in math class, we were taught that change is denoted with a delta. If you want to write the word change out, feel free. I just think it's simpler to use a symbol to describe a word. So delta V over delta T, a change in velocity over a change in time. Now, if you want to go a little bit more in detail, you've got to ask yourself, well, what did my math teacher teach me? What does a change mean? A change means a final value minus an initial value. So in our case, if our velocity is changing, it's final velocity minus initial velocity over the time. Now you can write the change in time as t final minus t initial, but if your t initial is 0, then you don't have to write your t initial, you just write your time. That's the amount of time it took for your velocity to change. So once again, you don't have to memorize anything, just ask yourself what these concepts mean to you, and you can derive these equations. The other equation that you've constantly seen regarding velocity and acceleration is simply you take your acceleration equation and you rearrange it. You can rearrange this 4 different ways, but one of the ways that you see often being rearranged is this. Once again, it's not a memorization idea, it's just these variables have been rearranged to solve, instead for A, they're being solved for Vf. You take the t over by multiplying both sides by t, that's how you get the AT together. And then you add both sides, you add a VI to both sides, that's how the VI comes into play over here, and then you solve for Vf. So you can rearrange this equation many different ways. You can rearrange this equation for t and say t is equals to Vf minus Vi over A. So it doesn't really make a difference. Either case, this idea is simple. It's about acceleration, it's about velocity. Now, for projectile motion, The first projectile motion problem that we discussed in class was about being dropped off from a cliff. So, for example, it's a horizontal cliff, and this ball is being dropped, it's being shot out horizontally. So there's this object being fired horizontally. It has a velocity in the x direction. And just like the log of pro activity in the previous video taught us that the x velocity is not going to change that much because air resistance is not going to play that much of a role in our experiments in the classroom. And in fact, in these problems, we can just neglect air resistance. So the x velocity will stay the same. So you can ignore that. I was trying to correct this line. It's supposed to be drawn horizontally. It's slightly at an angle. I'll have to figure out how to change that later. But anyways, back to the projectile motion problem. So the x velocity is not going to change. It's going to stay consistent because we're neglecting air resistance. In this particular case, you see if you fire a ball horizontally, it does not have a vertical velocity because it's going horizontally. There's a table, a flat table, that is causing the ball to travel horizontally. So it has no vertical velocity. Its vertical velocity is 0. However, as soon as the ball gets off of the cliff, it will start to develop a vertical velocity. And it will start to fall. And we'll get to this point. Its horizontal velocity will not change. But as it falls, it will start to develop a vertical velocity. Let's label the vertical velocity v subscript y. And then the ball will continue to travel. Its horizontal will stay the same because we're neglecting air resistance, but the vertical will get stronger and stronger and stronger all the way to the bottom. Now we're here. The horizontal is not changing. Vertical, it keeps getting stronger and stronger and stronger. It's become so strong that I don't even have enough room to draw the bottom of that arrow. But that's the vertical velocity. So what I want you to take away is, first of all, that the vertical velocity is 0. And the vertical velocity increases because gravity. Gravity is accelerating the ball downwards. So you need to know a couple of things. You also need to know the height of your cliff. In this case, we're going to label it as negative y. You can label it negative d, whatever you prefer, negative x if you want to. But it's because it's on the vertical axis, I'm labeling it negative y. So these are the important concepts. The takeaway here is the x velocity does not change. And if the x velocity does not change, you could call the x velocity, you could call it an average velocity in the x direction because it's not changing. And the other takeaway is that the vertical velocity will change. It will increase. So if somebody asks you, tell me how much time the ball takes to hit the ground, you've got to ask yourself, what are the concepts that are impacting how much time the ball will spend in the air? One of the most important things that impacts the ball's time in the air is its initial velocity, its initial vertical velocity. Its initial vertical velocity is 0. No one threw the ball down. It started off horizontally. It started off with a 0 vertical velocity. It only had a horizontal velocity. So you're going to say that the initial vertical velocity was 0. So that's a very important concept, the initial VI. And if you want to say this is initial vertical velocity, maybe you want to put a y there. The initial vertical velocity was 0. That's an important takeaway. The other important takeaway is, what else impacts the ball's time in the air? Acceleration of gravity impacts. How strong is gravity? If you were on the moon, would the ball spend more time or less time in the air? And the answer is it would spend less time because gravity is weaker on the moon. So gravity is another important concept. So let me circle the different concepts that you have to take into account. If somebody asks you how much time it takes the ball to hit the ground, the acceleration of gravity is going to be an important idea because that governs how much time the ball spends in the air. The initial vertical velocity is going to be important. That governs how much time the ball spends in the air. Did someone just toss it downwards, or did it just launch off a horizontal cliff? And then finally, how high is that cliff? So these are 3 very important variables that one has to take into account if you're trying to answer the simple question about how much time does the ball spend in the air. So on the next page, I'm going to write all 3 of these variables. We said, look, the initial velocity is very important. 0. The acceleration of gravity is very important, -10. And finally, the height of the cliff, whatever that is, some negative value, because it's downwards. We didn't put a number there, so I'm just going to leave it as negative y. If the cliff was 100 meters tall, you'd say negative 100 meters. If it was 1,000 meters tall, you'd say negative 1,000. Nevertheless, if you try to find the time, you're simply going to say, well, how are these three equations connected to each other? And they're connected to each other with one of your kinematics concepts. Now, I don't want you to get intimidated by this, because everything is going to simplify. Everything is going to drop out. Remember, your initial position is going to be classified as 0. So this is going to drop out of the equation. Your initial velocity is 0. So this whole thing, 0 times any variable is still going to be 0. It's going to drop out of the equation. So all you have left is your y displacement, how far did you fall, your acceleration of gravity, and your time. You notice that instead of a, I wrote down a negative g, because gravity, negative 10 or negative 9.8, and your time. So that's your actual equation. For a ball that's launching off of a cliff, if a ball is being launched off of a horizontal cliff, this is your most important concept to calculate the time it takes to hit the ground. Because from here, it's simply 8th grade, 9th grade, 10th grade algebra. If you want to solve for time, you rearrange this equation to solve for time. It's pretty straightforward. You take the 2 over by multiplying both sides by 2. That's a negative because it's the ball was falling down. I forgot to put the negative in there. So back to the algebra, you take the 2 over, multiply both sides by 2, divide both sides by g, take the square root, and you solve for your time. I'm going to do that all in one step. So that's how you find the time it takes the ball to hit the ground. The negatives canceled out, the negative displacement downwards, and the negative acceleration of gravity canceled out, so the negative disappeared. Good, because we don't want to put a negative underneath the square root sign. And this is your square root sign. There's a 2, and there's a 2 times the displacement divided by gravity gives you the time. So the cliff gets taller, the ball spends more time in the air. Gravity gets stronger, the ball spends less time in the air. You notice the displacement of the cliff, the height of the cliff is directly related to the time, and the acceleration of gravity is inversely related. In fact, it's the square root. So if you double the displacement, if you took the cliff, instead of 100 meters, you made it 200 meters, the ball won't spend twice as much time in the air. It'll spend square root of 2 times more time in the air. So it'll increase by a factor of square root of 2, because if you double this variable, the time will change by a factor of square root of 2. If you doubled gravity, if you went to a planet where gravitational acceleration was greater, that doesn't mean the time will become half because you've got a 2 in the denominator. No, it just means the time will decrease by square root of 1 over 2. So square root of half. So these are important concepts that you want to keep in mind when you're talking about projectile motion. Back to my diagram. Time for a horizontal ball can be determined using your equation 2 displacement divided by gravity. Now, the other important thing is this. What is the difference between a ball falling horizontally, because it just takes into account the displacement of the ball and gravity, and a ball just being placed here, being held here, and simply being dropped straight down instead of being launched horizontally? So a ball that's just placed, imagine a ball I'm holding, and I let it go. Well, that ball is also going to have a vertical velocity of 0 because I was holding it in place. Just like the red ball, it has a vertical velocity of 0. And if I let go of this black sphere and it falls, it'll start developing a vertical velocity also. Very similar to the red sphere. So what's the difference? And once again, the vertical velocity is so strong, I'm running out of room. I can't even draw the bottom of the arrow. So what's the difference between the vertical velocities of the black sphere and red? None. So keep that in mind. If you're ever asked to find the vertical velocity of the red sphere, treat it like a black sphere falling straight down. Initial velocity 0, acceleration of gravity negative g, displacement negative y. So there is no difference vertically between the black sphere falling and the red sphere being shot off horizontally, and then it falls in 2 dimensions where it's falling sideways and it's falling vertically. So if somebody asks you what's the time for the black sphere to hit the ground will be identical to the time for the red sphere, because you're still taking into account the same variables for both of them. So their vertical movement is identical because the 3 things impacting their vertical movement, initial velocity, acceleration, and displacement, are the same between both the red and the black sphere. Finally, last step. If anybody asks you how far the red sphere falls and hits the ground from the edge of the cliff, so if somebody says to you, look, here's the edge of the cliff, I want to know how far did the red sphere hit the ground from horizontally from the bottom of the cliff. Some people call it the range, how far down range it went. Well, if that's the case, it's a very simple idea. You've got to ask yourself, well, what's pushing the ball sideways? Is it the vertical velocity or is it the horizontal velocity? Common sense dictates that the ball's going sideways, so the vertical velocity is responsible for pushing the ball sideways. Well, the horizontal velocity is responsible for pushing the ball sideways. So did the horizontal velocity change? And the answer to that is no, because we're neglecting air resistance. So the horizontal velocity stays the same. And what is your horizontal velocity? Well, it is what it is. It may be 5 meters per second sideways, 7 meters per second sideways, 30 meters per second sideways. Whatever that velocity is, that velocity is going to impact how far the ball falls sideways, depending on how much time did you give that horizontal velocity to push the ball sideways. So once again, if anybody asks you the range, how far the ball falls from the bottom of the cliff, the only 2 things you have to take into account is how long did the ball spend in the air and what is its horizontal velocity. You multiply the horizontal velocity with the time and you'll figure out how far it fell. Because imagine the horizontal velocity was 2 meters per second. That means the ball is being pushed sideways 2 meters every second. And if the ball spends 5 seconds in the air, and it's going 2 meters every second, then how far does it go sideways in 5 seconds? 2 times 5 is 10. It would go 10 meters sideways. So if anybody asks you to find the range, only 2 things you have to take into account is the average velocity and the time. Now once again, these equations, these concepts, these ideas can be worked many different directions. You may be given on a particular day, you may be given the time. I may tell you, hey, the time is this. And I may ask you, how high is the cliff? Well, if I give you the time and you know gravity, you can solve for the height of the cliff. And once again, if I gave you the time, and let's say I give you the range, then I may ask you, look, I gave you the time and the range, tell me what the average velocity is. So you have to just say, okay, if I know the time and the range, divide the range by the time. That's how I'm going to know how fast is the ball going sideways, how fast is its average velocity, how fast is its horizontal average velocity. So this is going to be one of the problems in projectile motion. This is a ball falling off of a horizontal cliff. In the next few videos, I'll show you how to break down a ball that is being launched at an angle, not being shot off horizontally, because this was shot off at an angle of 0 degrees, because it's shot off horizontally. I'm going to talk to you about a ball that's being shot off at an angle. And we're going to analyze that concept just like we've analyzed this particular one.